This video is going to be going over sequences. So guys, this is the last new thing that you're going to learn when it comes to Algebra 1. We have two types of sequences. We have arithmetic and we have geometric. We're going to go ahead and talk about all about arithmetic sequences first, and then we'll come back and we'll look at geometric. So an arithmetic sequence is a sequence of numbers in which the common difference, or D, between any two consecutive terms is constant. Now, guys, when we are looking at sequences, we use what is called an explicit formula. And an explicit formula of a sequence allows us to find any term in the sequence without having to compute previous terms. You can input the term number in the formula and it will output the term. Now guys, we've seen these word input and output before. Remember, input stands for your X value and output stands for your Y value. So our equation for our formula for an arithmetic sequence is A sub n. So because this is like kind of on the bottom here, this is why I said sub n, equals A sub 1 plus D times n minus 1. Now, what do all these variables represent? So n equals the term number. So this, actually, let me go ahead and write that out. Term number. So this letter N will not always be in an actual sequence problem. It might say something like A sub 3, A sub 4, anything like that. Again, it's your term number. A sub 1, that is the first term. This is the initial term. And then, like we mentioned earlier, D is just your common difference. Now, you can find your common difference by finding the difference between two consecutive numbers. So we'll look at that here in just a second. So moving on, let's talk about, again, finding an arithmetic sequence. So for number 1, we want to write and simplify using the explicit formula to represent each arithmetic sequence in 1 through 3. So number 1, our sequence is 16, 19, 22, 25, and 28. So the things that I have to find in this problem, I have to find A sub 1, which is the initial term. It is the first term in the sequence. And I have to find D, which is my common difference. Well, the first term in this sequence is 16. So A sub 1 equals 16. Now, to find my common difference D, I'm going to take the second term, 19, and I'm going to subtract it by the first term, which is 16. So 19 minus 16 equals 3. So basically, guys, what that means is to get from 16 to 19, I added 3. Now what you're going to notice, if I take 19 and add 3, I end up with 22. If I take 22 and add 3, I end up with 25. If I take 25 and add 3, I end up with 28. So here, guys, this is my common difference. Every single time I am moving to the next term, it has a difference of 3. So my common difference is 3. So now that I have found my initial term and my common difference, I'm going to plug that into the formula. So I have A sub n equals my initial term, 16, plus my common difference, 3, times n minus 1. Now, guys, we're not done here. I have to simplify. So just like solving anything, our first step is to distribute. So I'm going to write A sub n equals 16 plus 3 times n, which is 3n, and 3 times negative 1, which is negative 3. Now we combine like terms. So I have A sub n equals, I'm going to drop down 3n, and I can combine 16 minus 3 to get positive 13. So here is my answer. A sub n equals 3n plus 13. Okay, moving on to number 2. We have 10, 22, 34, 46, and 58. So again, I have to find my initial term, and I have to find my common difference, which is D. So again, my initial term is the first term in the sequence, which is 10. And to find my common difference, to find D, I'm going to take the second term, 22, and subtract it by the first term. 22 minus 10 gives me 12. So here, to get from 10 to 22, I added 12. So I always want to check to see that I have the same common difference between terms. So 22 plus 12, that gives me 34. 34 plus 12, does that give me 46? Yes. Okay, 46 plus 12, does that give me 58? Yes. So here, my common difference is 12. So now that I have found the values of A sub 1 and D, Now I want to plug that into the formula that we have up top, which is a sub n equals a sub 1 plus d times n minus 1. So we're filling in our variables here. So I have a sub n equals a sub 1, which is 10, plus d, our common difference, which is 12, times n minus 1. Now, from here, our next step is to simplify the equation. So first step is to multiply. So I'm going to drop down the 10, and I am distributing 12 times n to get 12n. 12 times negative 1 gives us negative 12. Now, from here, go ahead and combine like terms. So combining like terms, I'm going to drop down 12n. 10 minus 12 gives us negative 2. So here is my answer. A sub n equals 12n minus 2. Okay, moving on. Let's go ahead and look at number 3. The first 5 terms of a sequence are a sub 1 equals 70, a sub 2 equals 62, a sub 3 equals 54, a sub 4 equals 46, and a sub 5 equals 38. Based on this information, create an equation that can be used to find the nth term of the sequence a sub n. Now, guys, this question was very similar to one that was pulled off of the benchmark. So, guys, this really threw some people off last year on the benchmark because they had never seen a sequence presented to them in this way. But basically, guys, all this is telling you is your first term is 70, your second term is 62, your next term is 54, your fourth term is 46, and your last term is 38. So now this looks a lot like what we were just doing. So again, I want to find my initial term, and I want to find my common difference. So my initial term here is 70. Now, to find my common difference, again, remember, we're going to take the second term of the sequence, 62, and we are going to subtract it by the first term. 62 minus 70 gives me negative 8. Guys, without really having to even do the math off to the side, I hope you can also realize the difference between 7 and 62 is 8. I went down, so I know I subtracted. The difference between 62 and 54 is 8. I went down, so I subtracted. Again, if I subtract 8 from 54, I get 46. And if I subtract 8 from 46, I get 38. So here I have the same common difference. Here, again, my common difference is negative 8. Now, again, I'm going to plug that into that formula that we have up top, which is a sub n equals a sub 1 plus d times n minus 1. So I get a sub n equals my initial term, which is 70, plus my common difference, which is negative 8, times n minus 1. Next step, distribute. A sub n equals 70 times negative 8 times n, which is negative 8n. Negative 8 times negative 1 gives us a positive 8. So from here, last step, combine like terms. 70 plus 8 gives us 78. So here, a sub n gives us negative 8n plus 78. So here is my final answer for this problem. Okay, looking at our next problem. Here it says number 5, but this is actually going to be number 4. So here it says write an explicit formula to represent the arithmetic sequence. Then use the formula to find the indicated term. So again, 2 things I have to find are my initial term and my common difference. So here the initial term is the first term in the sequence, which is 8. Now I want to find the common difference. So here basically what I want to know is what did I have to add to 8 to get to 17? So to find that, I'm going to take the second term, 17, and I'm going to subtract 8, which is the first term. 17 minus 8 ends up giving us 9. So here, this must mean that I added 9. So then I want to do it again. If I were to take 26 and subtract it by 17, I also get 9. So this lets me know I added 9. So then I check. If I have 26 and I add 9, does that give me 35? Yes, it does. Okay, now I check again. 35 plus 9. Does that give me 44? Yes, it does. So that is my common difference. My common difference is a positive 9. So from here, I'm plugging this into the formula. A sub n equals a sub 1 plus d times n minus 1. So a sub n equals 8 plus our common difference, which is 9, times n minus 1. Next step is to distribute. We have 8 plus distributing 9 times n, which is 9n. 9 times -1, which gives us -9. From here, our next step is to combine like terms. 8 minus 9 is going to give us -1. So here we have a sub n equals 9n minus 1. Now guys, I want to use this formula to now find the indicated term. I want to find a sub 26. This is my term number. So basically guys, what that means is I'm going to now substitute in that term for n to find the value when our input is 26. So I'm going to say 9 times 26 minus 1. So when I plug that into my calculator, guys, 9 times 26 minus 1, I end up with 233. Guys, what I hope that you have realized here is that basically all an arithmetic sequence is a linear function because it has a constant rate of change that is going by 9. Guys, I can literally type this function into my graphs. I can type in 9. Instead of n, it's going to be x minus 1. Press enter and then control T. And all I would have to do is go to the value of x, or value of x when y is 20. Sorry. All I would have to do is go to when x is equal to 26. And I would see that my y value is 233. Okay, so from here, let's go ahead and move on. We are going to move back over to the front page, and this time we are talking about geometric sequences. So a geometric sequence is a sequence of numbers in which the common ratio between any two consecutive terms is constant. So for a geometric sequence, here is our equation. A sub n equals a sub 1 times r raised to the power of n minus 1. So again, guys, here n stands for your term number. A sub 1 stands for your initial term. And r stands for your common ratio. So guys, to find your common ratio, you're going to take the second term and divide it by the first term. You'll see that here in just a second. So let's go ahead and look at number 5. So again, here up top, we have the formula for a geometric sequence, which is a sub n equals a sub 1 times r raised to the power of n minus 1. So two things I have to find here are my initial term and my common ratio. So my initial term is just the first number in the sequence, which is 7. And to find my common ratio, to find r, I'm going to take the second term and divide it by the first term. 14 divided by 7 gives me 2. Basically, guys, also think about it in this way. To get from 7 to 14, here I would add 7. Okay? Well, to get to 14 to 28, I add 14. So guys, this already tells me that this is not an arithmetic sequence. This is what's going to make it a geometric sequence. I want you to think about this in terms of multiplication. To get from 7 to 14, I multiplied by 2. To get from 14 to 28, I multiplied by 2. To get from 28 to 56, double check yourself here, but 28 times 2 is going to give us 56. Okay, if I take 56 again and multiply that by 2, I'm going to end up with 112. So here, my common ratio is 2. Guys, again, you should be able to take any two consecutive terms and divide the most current value divided by the previous value. And you should always end up with that common ratio of 2. So for instance, if I were looking at 28 and 56, 56 divided by 28 is going to give us 2. 112 divided by 58 is going to give us 56. 112 divided by 56 is going to give us 2. So that's just going to, again, confirm for us that our common ratio is 2. So plug this into the formula. We have a sub n equals a sub 1, which is 7, times the value of r, which is 2, raised to the power of n minus 1. And this is actually going to be my final answer. There is nothing else for us to find out or to simplify. Okay, number 6. Again, I want to find my initial term, and I want to find my common ratio. So my initial term is 243. And to find my common ratio, I'm going to take the second term of my sequence and divide it by the first term. So in my calculator, I'm going to take 81 and divide that by 243. And I see that I end up with 1/3. So here again, I'm going to plug this into the formula. We have a sub n equals a sub 1 times r raised to the power of n minus 1. So here I have a sub n equals my initial term, which is 243, times my common ratio, which is 1/3, raised to the power of n minus 1. Okay, moving on to this next problem. It says number 4, but this is actually number 7. So the first 4 terms of a sequence are a sub 1 equals -1, a sub 2 equals 6, a sub 3 equals -36, a sub 4 equals 216. Based on this information, create an equation that can be used to find the nth term of the sequence. So basically, guys, to make it look like all of the other sequences we've been looking at, this is just saying the first term is -1, the second term is 6, the third term is -36, and the fourth term is 216. So again, 2 things I want to find are my initial term, which is a sub 1, and my common ratio. So again, remember, a sub 1 is my initial term. In this case, this is going to be -1. Now, guys, what I want you to notice here is that I'm going from a negative number to a positive number, from a positive number to a negative number, from a negative number to a positive number. It's flip-flopping back and forth from negative to positive. So when that happens, guys, that should automatically be telling you that your common ratio is negative, because we know a negative times a negative is a positive, and a positive times a negative equals a negative. And when you keep repeating the pattern, this is what you end up with. But again, to find your common ratio, we're going to take the second term of our sequence, 6, and divide it by the first term, -1. 6 divided by -1 is -6. So here, our common ratio is -6. What I am doing here, I am multiplying by -6. So, to get to my next term, 6 to -36, I also, if I take 6 and I multiply that by -6, I end up with -36. So I did indeed multiply by -6 here. Okay, again, -36 times -6. When I do this, I end up with 216. So that again just confirmed that we multiplied by -6 here. But again, guys, remember, you can take any 2 consecutive terms. So I could have taken 6 and -36. And when I take the most current divided by the previous, I end up with -6. If I took 216, divided it by -36, I was going to end up with -6. Again, this is my common ratio. So now I want to plug this into the formula. I have a sub n equals a sub 1, which is -1, times my common ratio, which is -6, raised to the power of n minus 1. Okay, let's go to move on to number 8. So number 8 says, write an explicit formula to represent each geometric sequence. Then use the formula to find the indicated term. So, again, 2 things I want to find are my initial term and my common ratio. Well, my initial term is 2. My common ratio is what am I multiplying by to get to my next term? Well, to get from 2 to 18, I know that I multiplied by 9. But if you cannot do that math in your head, remember, take the second term, 18, divided by 2. When you type in 18 and divide that by 2 in your calculator, you get 9. Double check your answer. Take the next 2 terms, 18 and 162. Take the most current, 162, divided by 18. When I take 162 and divide that by 18 in my calculator, I end up with 9. So this means I multiplied by 9 to get there. Again, 1458 divided by 162. Plugging that into the calculator, we end up again with 9. So here I multiplied by 9. So my common ratio is 9. Writing this out as a formula, we end up with a sub n equals a sub 1, which is 2, times our common ratio, which is 9, raised to the power of n minus 1. So that is actually going to be our formula here. Okay, now we want to go ahead and find the 8th term. Before we find the 8th term, guys, I hope that you have realized that this looks oddly similar to the exponential growth and decay functions that we have been looking at. This looks an awful lot like y equals a times b raised to the power of x. The only difference here is that instead of x, this says n minus 1. So I'm kind of curious to see what will this graph look like, because again, this is just an equation. So I'm going to put 2 parentheses 9, close parentheses, raised to the power of x minus 1. Now, when you press enter, sure enough, guys, a geometric function represents an exponential function. So geometric is exponential, arithmetic is linear, just an FYI. So regardless here, I wanted to go ahead and show you that, but back to the problem, what is the 8th term? So here, this means that n equals 8. So to find this answer, I'm going to say 2 times 9 raised to the power of 8 minus 1. So in our calculator window, I'm going to say 2 times 9 raised to the power of 8 minus 1. And when we press enter, we end up getting back 9,565,938. Okay, so that finishes up your notes going over arithmetic and geometric sequences. But you should have also gotten a little half sheet, because on your assignment, it is also going to ask you to determine which functions represent arithmetic, which functions represent geometric, and which are neither. So using the sequences below, identify if the sequence would represent an arithmetic or geometric sequence. How do you know? Okay, so remember, arithmetic has a common difference. This means that you are adding or subtracting to get to your next term. Geometric means you are finding your common ratio. And here, the only way to get to your next term is to multiply. So from looking at number 1, to go from 2 to 4, I add 2. To get from 4 to 8, I add 4. And to get from 8 to 16, I add 8. So here, guys, I do not have a common ratio. So maybe it is a geometric sequence. Okay, so 2 times 2 equals 4. 4 times 2 equals 8. 8 times 2 equals 16. So because I have that common ratio here, this makes this a geometric function. Okay, number 2, we have negative 74, negative 49, negative 24, and 1. So first step, let's check to see if this might have a common difference. So I am trying to go from negative 74 to negative 49. So to find my common difference, this mental math might be a little hard for you to do in your head. So I'm going to take my second term, negative 49, and I am going to subtract it by my first term, which is negative 74. You notice we have double signs. Double signs means that we have to add. Negative 49 plus 74 gives us a positive 25. So what this means is that I added 25 to get to my next term. So now I want to check to see, am I adding 25 to get to the next? Again, when you're dealing with negative numbers, it might be a little bit more difficult for you to do that mental math in your head. So I'm going to take my third term, negative 24, and I'm going to subtract my second term, which is negative 49. Again, double signs means you have to add. Negative 24 plus 49 gives us 25. Okay, one more time. 1 minus negative 24. Again, double signs means that we have to add. 1 plus 24 gives us 25. So here I'm adding 25 between each term. So every single time I added 25, or because every single time I added 25 and it gave us the same term or the same output, this means that this is arithmetic. Okay, number 2. So to get from negative 2 to positive 2, I add 4. To get from 2 to 4, I add 2. To get from 4 to 12, I add 8. Okay, so this is not going to have a common difference. Okay, let's go ahead and go up top. Let's check to see if I have a common ratio instead. So to get from negative 2 to positive 2, I would take 2, divide that by negative 2. I end up with negative 1. So here I multiply by negative 1. To get from 2 to 4, I multiply by 2. And to get from 4 to 12, I multiply by 3. So here, guys, I also do not have a common ratio. So because I do not have a common difference and I do not have a common ratio, this is neither. Okay, guys, now that the video is completed, you have officially learned everything you need to know for Algebra 1. This video will be linked in Schoology if you need to watch it through again for further clarification. But other than that, go ahead and finish up your assignment, and I will see you on Monday.